So, part 2 of chapter 4. Logarithmic functions. So we have a logarithmic function is essentially the inverse of an exponential function. And I want to go through some simplifying. So letter A, log base 7 of 49. So I'm just going to rewrite this. Base 7 of 7 squared. So easy thing to remember, if the log base is the same as the base of the exponent, they will cancel each other and give you 2. The real reason why is because the exponent can come in front and you get this. But this is the same thing as the value of 1. So if you look at letter E, log of 0.001, that is the same, if I can get that 1 to show up, log base 10 of 1/1/10,000,000th, which is the same as log base 10 of 10 to the negative 3 power. So using the same rule I used before, that equals negative 3. Moving on, the domain of a log function. So any log function, domain is where x is in the real numbers and x is greater than 0. So the easiest way to find the domain for the function that's up there, take what's in the parentheses or inside of log and set that first equal to 0, and you get 4 is equal to x squared and x equals plus or minus 2. And then what you want to do is make a number line, negative 2, positive 2, substitute in 2 and you'll get 0. So those are not part of the domain because you can't take the log of 0. If you put in 0 into here, you end up with the log of 4, which we can find. So the domain is the open interval of negative 2 to 2. Properties, basic properties that you should know, obviously the fact that log of 1 is 0, any base. Log base b of b is 1, the one I was using. The fact that log base b of b will cancel and give you just x, and b to the log base b, that's one we haven't seen just yet. So as long as these are isolated, you can essentially cancel and the x will drop down. All right. So let's use some of these properties. Some basic ones to look at would be anything we haven't necessarily done. Let's do part D is 10 log base 10 to the 47, obviously, 47. Letter I, making sure you understand that e to the ln of 5, ln's base is little e, so that is 5. The other ones we have done something similar. The ln of 50, finding that very interesting. I don't really know why they have the ln of 50 up there, because we haven't done enough rules to really do anything else to it. Let me see. So your book actually just has you putting that in the calculator. So I was correct in saying can't really be simplified. So the properties that you should know, if you have, this is called the condensed side. This is called the expanded side. And these rules get confused all the time. If you have a product in the condensed form, then you can expand it to a sum. If you have a quotient in the condensed, then you can expand it to a minus. Those are the major ones. We already talked about the fact that the power can go in front. Most of the times, people are pretty good about that rule. So let's look at, let's do letter D. Log base b of x cubed over y squared. So the fraction would be the primary operator. So a fraction means I can subtract. And I would use the same exact base. And then the exponents can come in front. Oopsie, that's supposed to be a 2. There we go. And then we can also do letter F, which is log of m plus n over n. And same thing, first thing I'm going to do is separate with a minus. And where people get confused, there is no rule that will expand this. So please don't try. A sum inside does not get expanded. It's not one of our properties. Single quantities. So let's do letter E. Log base 3 of m plus log base 3 of n minus 2 log base 3 of p. First thing I'm going to do is move this up here, and then I'm going to rewrite everything else just so I show my steps. This minus here tells me I'm going to have a quotient. Oopsie. So I'm doing this step by step. And then the other minus says I'm going to divide these two terms, which ends up being that I have m over np squared. All right, moving on. Change of base formula used to evaluate log of bases other than E or L or log 10. Your calculator can't do this. So to change the base, you take the base, put it on top, take the base on the bottom, put it on bottom. So you can use log, or, which I actually use more often, I use the ln instead. So the base is at the base. That's how I remember which order it goes in. Exponential and logarithmic equations. So this section is a little bit longer just because I figured that now is a time that you need to learn to solve, and I find that that's where students tend to be a little bit weaker. So I have 2 is equal to e to the 0.075 to the t. If I want to look at it, first thing you want to do is isolate your base. So meaning there should be no plus or minus, and there shouldn't be a coefficient. It's isolated, which means I can take the ln of both sides. So I'm going to squeeze it in on this line. So I have the ln of 2 is equal to 0.075 t, so t is equal to ln of 2 divided by 0.075. And then you would put that in the calculator. Solve the equation. 3 to the x minus 4 is equal to 24. So same exact thing. I'm going to look and make sure that the base is isolated, no coefficient, nothing plus or minus all the way at the end. All it has is its power, so we're good. 2, take you can essentially take the log base 3 of both sides, but you'll notice I have a habit of always taking the ln of both sides. And here's the reason why. When I do that, this comes in front, because it's a power. Then I get x minus 4 is equal to ln of 24 divided by ln of 3, which does not simplify to ln of 8, by the way. And then x is equal to, put the ln of 24 in the calculator, divided by the ln of 3, and add 4 at the end, and you'll get the final answer. 3 significant figures, please. You invested $1,000. Compounded quarterly at 6%. How long will it take for the investment to reach $2,000? So, compounding quarterly, A is equal to P times 1 plus R over N times NT parentheses around. So, 2,000 is equal to 1,000 times 1 plus R, which is 0.06, divided by N, which is 4, times 4 T, because we want to know how long. So, I feel as though we even did this in a different video. Divide by 1,000. Okay, I'm going to change this value. I got it over here, 1.015 to the 4t. And then same thing, your base is isolated, so you can take the ln of both sides. And we'll come over here. And now that I have the ln of both sides, I'm going to write the next line for you. Move the exponent in front, ln of 1.015. And then if I want to isolate t, I would divide both sides by 4 ln of 1.015. Put that in the calculator, you should have your final answer. The next example, the bacteria will cause strep throat, will grow at a rate at about 0.023 per minute to the nearest whole minute. How long will it take for these bacteria to double in number? So you'll notice that there's no initial amount. All we know is that we want to double the amount that we had using this rate. So if we talk about an initial amount being a sub 0, double that would be a sub 0 times 2. So I am going to use this formula, and time will be in minutes. How long will it take? So right now I actually have two variables. I have t as a variable, and then I have a sub 0 as an unknown. Not a variable, but at least an unknown. But when you divide both sides by a sub 0, it actually cancels, so the amount that you start with really doesn't matter. I just need to know the rate. So this turns into a simple problem. The base here is isolated. So I'm going to take the ln of both sides. The ln of 2 is equal to t ln of 1.023, and then t is equal to ln of 2 divided by ln of 1.023. And it would be in minutes. Oh, let's see. After how many days is there only 5 grams remaining? So I think this is similar to what we've done so far. The only difference is there is a coefficient. So it says 5 is equal to 20 e to the negative 0.087 t. You actually have to divide by the 21st before doing anything else, because the e, which is the base, is not isolated. You have to isolate the e first with its power before I can use the basic rule of ln of both sides. So the ln of 1/4 is equal to negative 0.087 t ln of e, but ln of e is 1, which makes this problem a lot nicer. So divide by your negative 0.087, and that is your t value. Solving logs. So in this case, you want the exact same concept. You want to isolate the log base. So if there was a coefficient in front or a number added or subtracted, you want to move those terms first to the other side. Otherwise, I can take that base and raise the entire equation to that base. So what it really looks like is 3 to the log base 3 of 2x minus 5 is equal to 3 to the second power. And remember that a big base and a little base will cancel. 2x minus 5 is equal to 3 squared, which is 9. So 2x is equal to 14. X is equal to 7. Moving on. Solve for x in terms of k. So I want x by itself. So same thing, I'm going to look and make sure there's nothing in front, nothing in back. That means I can take both sides to the 2. 2 to the log, and you don't have to rewrite this step. I'm only doing it for your notes. Normally I really don't. All right, so log base 2 and 2 will cancel. 5x is equal to 2 to the 3 plus k, and x is equal to 2 to the 3 plus k, whole thing divided by 5. This one, problem. We have 2 logs. So if you remember, I said you had to isolate your log. When you have 2 of them, they need to condense into 1 before it's isolated. So right now, that is not considered isolated logs. There is this here, but there's something in front. This one has something added or subtracted to the back, so therefore they are not isolated. So if there's a expanded with a plus, we're going to change it to a condensed with a multiply. Those are both inside that log equals 4. Now the log base 2 is isolated. What I mean by that is no coefficient, no value added or subtracted. Take 2 to the both sides. This cancels, and I have x times 10 minus x is equal to 2 to the 4th is 16. So I have 10x minus x squared equals 16. I am going to move the x squared to the right side so it's positive. Subtract 10x plus 16 equals 0, and I bet you it is factorable. X minus 2, x minus 8, therefore x equals 2, and x equals 8. Here's a major issue though. Major issue. You have to go back and look at your log problems and make sure it's part of the domain. So what I mean by that is, you see how it says log base 2 of x, and then it says log base 2 of 10 minus x? We really should have found the domain first. So the domain says that log can only take positive values. Can't even take 0. Both are greater than 0, so we're good. Then here, you should notice that 10 is the value that would make it 0. We can't include 0, but if I put in 11, it makes the value negative. Log can't take negative values. So the domain for this is x is less than 10. Both are less than 10, so this one works and this one works. So you do have to think about domains when you do log equations. So the next one, so I'm going to do your domains first. So x minus 2 has to be greater than 0. So we just solve it just like it's equal to 0. Put your 2, can't equal 0, but if I put in 3 and I do 3 minus 2, I would get a positive value. So there's that part of the domain. And then 2x minus 3 equals 0. X equals 3 halves. Same thing, 3 halves goes here. Open circle, because if I substitute in 3 halves, you'll get the ln of 0, which we can't have, but put in 100. 100 would be to the right, so this is the domain. The final domain over here would be x is greater than 0. So if you combine all of them, the actual domain for the problem would be that x must be greater than 2 to combine all 3 domains. So now I'm going to actually solve. I just want to make sure that my final answer is x is greater than 2. So on the left side is a sum. So I'm going to do x minus 2 multiplied by 2x minus 3 equals ln of x squared. Now this is nice because once you condense, they both have an ln, and I'll show you the step, but really you get to just bring down the powers. So you get x minus 2 times 2x minus 3 equals x squared, and we get 2x squared minus 7x plus 6 equals x squared. We get x squared minus 7x plus 6 equals 0. X minus 6, x minus 1 equals 0. X equals 6, x equals 1, but x equals 1 is not in the domain, so the only answer could actually be x equal to 6. Let's see, so what we call these are extraneous solutions. Therefore, it is not an actual solution to the problem. All right, moving on. We're done. So there is the second video for chapter 4.